So in Unit 4.3, we're going to tackle substitution. Now, we've already found the solution to a system of linear equations by graphing, but like we said earlier, it's not always going to be the most accurate method or way of arriving at that answer. So we do have a couple of other ways that we can get to solutions for linear equations. And the first one is, again, substitution. So it's exactly the way it sounds. You're going to substitute one value in for another. Now, in this first problem, we've got what is the solution of the system? And it's telling us to use substitution. And that system of equations is y equals 3x and x plus y equals negative 32. So whenever we're doing a system of linear equations using substitution, the first thing that we want to do is identify what are our four variables. So in this case, we've got a y, we've got a 3x, we've got an x, and we've got a y. And normally what we're going to do is we're going to choose one of those four variables to isolate, because we need to come up with a quantity that that variable is equal to. So in this case, we have y equals 3x already. We already have a variable that's been isolated in the equations that we've been given. So what we're going to do is we're going to take that 3x and we're going to substitute that in for the y in the second equation. So instead of having x plus y equals negative 32, we're going to take that 3x in, we're going to put it in for y, and we're going to have x plus 3x equals negative 32. Because we've now substituted a value that we know is equal to y, but it has the variable of x, we now have only x's in this equation. And because we only have a single variable in the equation, we can now solve for that variable. So x plus 3x is 4x. 4x equals negative 32, divide out the 4, you get x equals negative 8. So now we know the value of x, and x is equal to negative 8. So what we've got to do is we've now got to take that negative 8 and plug it back into the first equation. So one of the important things that you've got to do with substitution is whenever you choose an equation to work with, the next step in the process, you've got to use the other equation. Then when you're done with that step in the process, you've got to go back and you've got to use the original equation. Then when you go back and check, you've got to use the other equation. So you're constantly bouncing back and forth between those equations. Now that we've got that x equals negative 8, we're going to again use y equals 3x, and we're going to plug in negative 8 for x. So we get y equals 3 times negative 8, which is y equals negative 24. Now, the solution that we've got so far is negative 8, negative 24. Again, we're going to write it as an ordered pair. We do want to go back and check and see if we've done our work correctly. So we're just going to substitute those values in to the other equation now. So we're going to go back to x plus y equals negative 32. We're going to plug in negative 8 for x and negative 24 for y. Negative 8 plus negative 24 is negative 32. Negative 32 equals negative 32. So we know that we've got the correct solution. In problem number 2, we're going to again use substitution, but we've got a little bit more complicated setup to begin with. In this case, we've got 3y plus 4x equals 14, and negative 2x plus y equals 3. So again, look at your four variables and look at the coefficients that are attached to those variables. If we have any coefficients that are 1, that's the variable that we want to isolate. So we've got 3y, 4x, negative 2x, and 1y. So that 1y is the one that we want to isolate. So when we isolate that y, we end up with y equals 2x plus 3. We now know the quantity that y is equal to. So we can take that quantity and substitute it into the first equation in place of y. So instead of 3y plus 4x equals 14, we'll have 3 times 2x plus 3, then plus 4x equals 14. Distribute the 3 through to both of those terms. You get 6x plus 9, then plus 4x equals 14. Combine like terms, 6x plus 4x is 10x, then plus 9 equals 14. Then start isolating the variable. So subtract 9, you get 10x equals 5, divide by 10, and you get x equals 1/2. So now we know the value of x is 1/2. We can substitute the 1/2 into the other equation, the negative 2x plus y equals 3, and we can then solve for y. So when we do that, we get negative 2 times 1/2 plus y equals 3. Negative 2 times 1/2 is negative 1, plus y is equal to 3. Add 1 to both sides, and you get y equals 4. So right now our solution stands at 1/2, 4. Go back and check your work. 3 times 4 plus 4 times 1/2 is equal to 14. So you get 12 plus 2 is equal to 14, or 14 equals 14. So we know that that solution of 1/2, 4 works for both equations, and that is the solution. In problem number 3, we've got a word problem, which is really what this is all made for. It's trying to determine the relationship between two values or two variables given a set of circumstances. So the set of circumstances that we're given is a snack bar sells 2 sizes of snack packs. A large snack pack is $5 and a small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? So the first thing we got to do is translate this entire thing from English to math. We know that a large snack pack is $5. So we're going to say that L is equal to 5. Then we know that a small snack pack is $3, so we're going to say that S is equal to 3. Then we know that the total amount of snack packs sold between large and small was 60. Then we know that the money that was made off of those snack packs was $220. So what we want to do is we need to set up an equation where we get something that equals 60 and something that equals $220. So in order to figure out that 60, the 60 is just the number of snack packs that were sold. Well, how many different types of snack packs are sold? You have 2. You have the large and the small. So between the large and the small snack packs, you had 60 snack packs that were sold. So L plus S equals 60. Then for the 220, how did you arrive at making $220 off of those 60 snack packs that were sold? Well, we know that every large snack pack is $5. So 5 times large snack packs plus 3 times the small size is going to equal 220. So 5L plus 3S equals 220. So the next part of this would then be to take your two equations and figure out which variable of the L, S, 5L, and 3S do you want to isolate? So I've chosen to isolate for the S. And so that means that I'm going to move the L to the other side, and I'm going to end up with S equals negative L plus 60. So I'm going to take that quantity of negative L plus 60, which I know is equal to S, and I'm going to substitute that into the other equation for the S. So I'm going to do 5L plus 3S equals 220, and it's going to become 5L plus 3 times negative L plus 60 equals 220. Go ahead and distribute the 3 through to the negative L and the 60, so you get 5L minus 3L plus 180 equals 220. Combine like terms, so 5L minus 3L is 2L. Then start isolating the variable, subtract 180, so 2L equals 40, and then divide by 2 to get L equals 20. So now we have our first coordinate, or we have our first piece of information, which is that the large snack packs, there were 20 of them that were sold. So the next part of this then is to substitute the 20 in for the L in the other equation. So L plus S equals 60 becomes 12 plus S equals 60. Isolate S, and you get S is equal to 40. So our solution should be 2040, or 4020, depending on which one is your X and which one is your Y. Really what we want to know is 20 large ones were sold, 40 small ones were sold. Then go back and check your work. So go back and use the other formula now, or the other equation, which was 5L plus 3S equals 220. So 5 times 20 plus 3 times 40 equals 220. 5 times 20 is 100. 3 times 40 is 120. Add those together, you get 220, and 220 does equal 220, which means that we do have the correct solution. For problem number 4a, we're being asked how many solutions does each system have? So that remember that whenever we have a system of linear equations, of two equations, then we can have either no solutions if the lines are parallel, which means if they have the same slope. We could have infinite solutions, which means that the lines are exactly the same equation. Or we can have one solution if the lines overlap at one point. So we're given x equals negative 2y plus 4 and 3.5x plus 7y equals 14. So what we can do here is we've already got the x isolated. We know that x is equal to negative 2y plus 4, and so we can plug that into the other equation. Now what I've done is I've converted the decimal to a fraction. You could also, if you wanted to, convert the decimal to a series of integers. So instead of having 3.5, the way that you get 3.5 is to multiply by 2. So if you wanted to go that route, then you could multiply every single term in that equation by 2. That would give you 7x plus 14y equals 28. I've gone ahead and I've just used the fraction. So 7 halves x plus 7y equals 14. Then I'm going to plug in the negative 2y plus 4 in for that x. So now 7 halves times the quantity negative 2y plus 4 plus 7y equals 14. With 7 halves and negative 2, the 2's cancel out and you're left with negative 7y. With 7 halves and 4, the 2 cancels out, the 4 becomes a 2, so 7 times 2 gives you 14. Then plus 7y equals 14. So then we combine like terms. Well, negative 7y plus 7y is 0y, so we just get rid of the y's, and all we're left now with is a 14 equal to 14. This is a true statement. We do know that 14 is equal to 14, and since we don't have any variables left, we know that this has to be infinite solutions because we got a true statement when we work this problem out. We're going to do the same thing in 4b. We've got y equals 3x minus 11 and y minus 3x equals negative 13. So we already have y isolated, which means we know that y is equal to 3x minus 11. So we're going to take that quantity and we're going to plug it into the other equation. So y minus 3x equals negative 13 becomes 3x minus 11 minus 3x equals negative 13. Now, since there's nothing we can do on the inside of the parentheses, and there's nothing on the outside of the parentheses that's going to change the quantity, we can just drop the parentheses and combine like terms. So 3x minus 3x is 0x, and this time we're left with negative 11 equals negative 13. Now we know that this is not a true statement. So since this is not a true statement, this means that there are no solutions to this problem. If we were to graph these two equations, then we would see that they're parallel lines, they never cross, and that means no solutions.